Okay, gang. Here we go. Homework questions. Anybody got one? Moses, I thought you had a homework question. I don't know my homework.
I've done the homework for the week though.
Yes,
Can we do 6 or 7?
6 or 7. Let's just pick one. Let's do 6. Okay, so here's the directions. Well, here's the equations for 6. Anybody remember, what do we call this kind of equations? Guys, I didn't write it on the board yesterday. Parametric. These are parametric equations. Okay, so our first task is to find the points determined if we let t be, they give us a whole string of numbers. Okay? I'm not going to do all those, Jamal. They're all done the same way, but I'll do a couple of them. So if I let t, I'm finding points now. So if I let t be -3, then x would be -2, and y would be, okay, watch it, it's -3, so it'd be 9 plus 60, 15, if I put in -3.
Okay.
And then if I let t be 1 is another number in the list they gave me. If I let t be 1, x would be 2, and y would be -1. And I can just go on doing that with all of the t values that they gave me. Okay, so I'm just going to have a big string of points. Now the second part of the problem said take these 2 equations and make them into 1. Now who remembers how we did that yesterday? Julian.
We set one of the problems of t equals, so then we can substitute.
And this would be the easy one to do, right? So we would say, what does t equal? T equals x minus 1.
Put that into the y.
And then we take this guy right here, he is t, and we can put it right here in for these t's. Moses, are you watching? I'm substituting. This is what you want me to do. So we're solving for t, and then we're taking that t value and plugging it in here. So we have y equals x minus 1 squared minus 2 times x minus 1. So that's x squared minus 2x plus 1. I FOIL minus 2x plus 2. I distributed. So my final answer is x squared minus 4x plus 3. Which is a quadratic. So, Jamal, if I were going to graph this now, what shape would it be since it's a squared equation?
It would be
A parabola. And if I actually finished the first part where they told me to find all these points, I'd have a whole bunch of points that I could go ahead and plot on there, and they would make my parabola. These points would make my parabola. Lindsay?
How did you get the first point minus 2x?
When you FOIL this, I did it in my head, but if you FOIL this out, you get minus x minus x. All right, let's go back now and pick up where we left off yesterday. Remember, you have your graph paper. Everybody should have some graph paper. We are probably going to run out, and we're going to need more graph paper eventually. So it is right here. Right here. If you need more, help yourself. Please don't take more than you need. Yesterday we did the first 2 problems. So we're not going to redo those. Yep, this is the original. I'm going to go ahead and redraw the original. This is the original picture. which is drawn for you on your paper. There it is. And we're ready for problem C, which says y equals f of x plus 2. Now you gotta remember what adding 2 out here does. Move it up 2. So we're gonna redraw the picture on our graph paper, and we're gonna take every single one of these points and go up 2. So I don't care where you start. If we just start here, and everything's gonna go up 2. That means, okay, this is negative 3, 0 right now, so it's gonna go up 2. So it's gonna be up here. Now where's this one gonna be? It's at negative 1, negative 2. So it's gonna be at negative 1, 0, if it goes up 2. This isn't hard stuff, folks. We're taking every point and picking it up 2 units. So where's this one gonna go? Up to 2? So there's your first little V thing, raised up 2 units. Now that point is over 1, up 1. Well, now he's gonna be over 1, up 3. There's your little that V thing. And there it is. Everything picked up 2 spaces. All right, let's look at D. What's happening there? It goes left 2. So you're going to pick up this picture, and you're going to take every point and move it over 2. So it doesn't matter really where you start, but you start here. It's at negative 3, so it's going to be all the way over at negative 5. So you're going to have this exact same picture, just slid over 2 units. Everybody okay with that? Now this one is going to challenge us a little bit, because there's 2 things happening here. You can do it however you want, but I'm going to do it in 2 steps. So I'm going to start right here. What does that do? Forget this negative, what does this do? Goes right one. So I'm gonna do that first. I'm gonna take this picture and I'm gonna pick every point up and move it 1 unit to the right. After a while, you get kind of so you know what this thing looks like. You've drawn it so many times. Now, is that the answer to the question?
No.
No way. What does this negative do? We talked about this yesterday. If it's out in front, it flips it upside down. So now you're going to take the picture that you just slid over, and now you're going to flip it up. Or down. Flip it upside down. So the answer to the question, the final answer, is what I have there in green. You can do that all in one step if you are capable. I mean, if you can handle all that at once, feel free to do it all in one step. I always break it up because my mind is feeble. Okay, is everybody doing all right? Have you started the next one? What's happening here? F of negative x minus 3. Two things. Forget that minus 3 for a minute. What happens there? It flips across the y-axis. So I'm going to go ahead and take my original. Oh, I hope I have enough room. I'm going to take my original and move it this way. So this little v, instead of being on the left side, is now going to be on the right side. And the rest of it's going to be over here on the left. So that's this part. I've only done that part so far. Are you okay? Now what do we do here? Down 3. So now we're going to grab every single one of these points and we're going to pull it down 3 units. So the answer is the purple picture. Minute, as soon as we finish these last 2, we're going to go on to the next problem, and you guys are going to come to the board, so get ready. Let's look at G. Can anybody explain what is happening in this problem? Okay, so it's upside down and across the y-axis. That is a lot to handle, so I'm going to do one at a time. It doesn't matter which one you start with. What would you like to do first? Do you want to flip it sideways or flip it up and down? Sideways? All right. So that means everything on the left comes over to the right. So that takes care of this part. Remember, a negative on the X takes you this way. Now that negative flips me upside down. So the V's that were down are now up, and vice versa. So my answer is the purple. Oh my gosh, look at H. What's happening with H? Three things are happening. Now, when there's this much going on, we start inside the parentheses first, just like we do with normal operations. So step one's gonna be where's shift left. Nathaniel?
So on the last one, sorry, I'm a little bit late on the question. Which one flips it across the
This one?
x-axis? Yeah.
Okay, this is flip across the y-axis is this.
Okay.
This goes across the y-axis. This goes upside down.
Okay. All right.
Okay, so here's our problem. So we're gonna start right here. We're gonna do this part first. So that takes every point, I gotta go back to the original now. Takes every point 1 unit to the left. Does that make sense to you? Remember, we're going 1 unit to the left, opposite. Okay, so I took care of that. Now I'm gonna take care of that. What does that guy do? Upside down. So now I'm gonna take all these points and turn them upside down. And now what does this do? Takes every one of those points and brings it down 3. I ran out of room here. That actually should be down a little bit farther, but I ran out of room. So the purple is our final answer. We moved everything left, turned it upside down, dropped it down 3. Okay? Now, if you turn the page, you'll see another shape, some other shape there, which is okay, we're getting kind of sick of this one. So it's just another shape. I want everybody right now on your graph paper to do problem A. If you're a quick worker, work on, we're gonna do all these, so go ahead and work on all of them. But as soon as you get A, let's see, how many can we put up here? 3 maybe? Let's do A, B, and C, and have you come up and put them on the board. So everybody's working on A, B, and C.
thinking these two would be right.
Okay. I got my classes mixed up. We haven't talked about that yet. Whoa. Did you all notice that that's not a +2? That's a ×2. So you're sitting there thinking, well, Mrs. Ford, now wait a minute. What does that mean? Well, let me graph my original up here and let's talk about that. You were thinking, you wacky old woman, you haven't told us yet how to do this. Okay, so there's the original. What a multiplier does is it changes the size of the picture. Now, what does an add or subtract do? When we do +2 or -2, what does that do? It just moves it, right? Nothing changes, it just picks it up and puts it down somewhere else. When you put a multiplier in, it changes the size. A multiplier out in front makes it, well, if it's a 2, it multiplies the height. Multiplies the height of the curve. So if there's a number out in front, your picture's either going to get taller or smaller. We call it a stretch or a shrink. It's going to either get bigger or smaller. If you put a 2 out there, it's going to make everything twice as tall. So see this mountain or this thing right here? How tall is he? He's 2. Well, when I draw him tomorrow, he's going to go all the way up to 4. All right, we'll pick up here tomorrow. Thank you. Have a good day. You got homework tonight. You can do it.
Chicken, we don't ride, we don't go on dates.
What in the world? What's that sweatshirt? Huffington University. Where is Huffington University?
No idea.
Oh, it is. I get the emails.
Well, how do you have the sweatshirt if you don't even know anything about the university?
Got it from my brother. Are your brothers back still?
Brother goes to Huffington?